Alrighty then, so hello folks and welcome to this afternoon's PL/SQL office hours. For any of you who are expecting to see Stephen Feuerstein looking at you and talking to you now, I'm sorry to say that he's unfortunately not very well today, so he's asked me to stand in and help manage things along. In any case, I don't think it's too big a deal because today we've got a guest speaker, Parveen Kumar, who's going to be talking to us about VPD. So I will give a brief introduction. Before we do that, as always, we've got questions, put them, well, we've got two places to put questions now. There's the Q&A window and the chat window. So note, if you put things in chat, by default, they only come to us panelists. So the rest of the attendees can't see them. If you put them in the QA window, then everyone can see them, and also we can thread things. You can respond to individual stuff. So it's a bit easier for people to follow if you put stuff in the QA window. But I'll be keeping an eye on these, so wherever you put them, we're happy to go ahead. All right then, so that's enough of that. I'll bring us back over to the slides briefly. So there we go. So as I say, we're going to be talking about VPD, and we have a real-world example of this, and this is healthcare. Now, this is one of these environments where you really want to be sure that people are only seeing the information that they are supposed to be. You know, if you go to see your doctor, you want to be sure that they're only looking up your notes. If for some reason, you know, you've got access to an online portal where you can see medical information, you want to be sure you and only you can see that information. The people administering a clinic should only be able to see information relative about the patients relevant to them, about the people attending the clinic, and so on and so forth. So this is an area where it's really key that people can only see the right information at the right time. And virtual private database is a great way to do this. And as I said, we've got our guest speaker, Parveen Kumar, who's going to be talking us through this and explaining how he's done it. So he's a Java and Oracle developer who's been working at Wipro and is also in the UK along with me, which is great. It's nice to have someone over here as well. And so he's been working for quite a while now in developing applications, mainly with Oracle database. So with that, I will now hand you over and say hello. Do you want me? I'll stop my share so you can show whatever you need to do, Parveen. Okay?
Yep, sure.
All right then, go ahead.
Let me start sharing my screen now.
There you go.
Okay, I hope that everybody can see my screen now.
Yeah, we've got your desktop at the moment.
Okay, so I'll briefly start with, I think Chris has already covered my introduction, so I'll not waste the time doing that. I'll just open a small document which I prepared for this presentation to just give a brief introduction about what the VPD is all about and how we can basically simplify this and to make it more and more understandable to everyone. So VPD also is known as the RLS. I don't know why that is, because RLS means row level security and VPD means virtual private database, which also provides the column level security. So it is a security feature which was introduced in starting 8i, and it is still available, and I think soon will get deprecated starting, I think, in 12c. They are giving us, I think, RAS in place of VPD, but they both still coexist altogether. RAS stands for Real Application Security, which is basically an enhancement to the VPDs. And as Chris said, I think the main purpose of this is to basically allow or prevent the users from seeing each other's data, basically, and just to stick to what they are supposed to see in the application, or if they are from the reporting team, or if they are doing something else in the database or in the application. So let's consider a general example. So it's a very, very general example, not in terms of complexity with the Oracle database. So just let's in the offices or in the public places, when we have a cupboard, it has got like several storage compartments in it, and each user has got its own their own locks, and that's what basically it means. So everybody has got their own keys to access what they are supposed to access. They cannot go and look into others' logs and things. So that's what, in general, that's what I think Oracle VPD lets us to achieve in terms of security. Why basically? So if we speak about security, we can argue saying that we can achieve that same stuff using the generic roles and responsibilities, or the privileges which we have in Oracle database. But that doesn't comes handy when we have like common objects which are shared across multiple users. And that's the general idea of having applications where the users basically access the common tables or the views or synonyms. They basically hit the same table, underlying table, and then it has got a whole lot of data which which basically doesn't belong to all the users for them to see. So Oracle VPD basically prevents that, and what it does is, in essential, it creates a transient view when we apply or attach a VPD policy to an object. It basically creates an in-memory transient view and adds a where clause with the predicate. Now that predicate should be returned by a function which is attached to the policy name when we create that policy. And there are a few assumptions when we create that function. So like what parameters it can accept and what it can return in terms of the where clause or the predicate. So I'll be giving a brief overview, and obviously this document I'll share it after the presentation. It has got all the links to yeah, before going to the links, I think the DBMS_RLS interface is the main package. It is also in some places we use DBMS_FGA, which is also known as the fine-grained access. So, but predominantly, I think we use DBMS_RLS most of the times. And in the below table, these are the 12C documentation links to each and every API it provides in terms of handling the VPDs. The main focus of this presentation will be to add the policy, drop the policy, and grouping the policies together. And yeah, adding the context, creating a database level trigger to further enhance the security of the applications. Yeah, so earlier I said that when we create a VPD function which returns the main predicate of the where clause, there are some assumptions which we should keep in mind. So that function can only take two arguments, which is known as the object schema and the object name to which you are trying to attach that policy to. The parameter names can be different, but the order should be same. So the schema name and the object name should be the only two parameters which it should have. And these two are string types, or varchar2 types in an Oracle word. It should be able to return a filter predicate, or it should return null. Or otherwise, what will happen is nobody will be able to access the table, because the policy function, if it results in an error, the table just, whenever somebody queries that table, it returns an error saying that the policy function attached to it has got some issue with it. Yeah. Then we talk to the scenarios. So I'm using a basic example of employee details table from that. I've created in the HR schema with a combination of departments and their. So what I'll do is, yeah, let's dive directly into the database. I'll talk briefly about what the kind of setup I'm using. So I'm using, for this session purpose, I'm just using a Toad trial version because I don't use SQL Developer in my day-to-day work, so I'm more familiar with Toad. So I've just downloaded a trial version of it, and then using Oracle Database 12c. And all the code which I'll be demonstrating is tested on Oracle 19c and 18c and 12c, so there shouldn't be any issues when we want to implement the same stuff in these versions of the databases. Yeah, so I've got it. So when we before implementing a VPD, we should have. So I think there's a common saying in when we try to apply the restrictions or the access restrictions, or in terms of security, we want to achieve the minimum privilege rule. We want to follow that minimum privilege rule for each user who is supposed to access the application. But before doing that, we should before doing that, we should have some users, or at least a user, which is commonly as an advanced user we can refer as, because it's not a good practice to create objects in the sys schema or the system schema. So we shouldn't be, unless of course we are administrating the databases, we shouldn't be creating or doing anything in the sys schema. So for this purpose, I've created a user called util, which will handle all the VPD related functionality. And then I've enabled the HR user from the 12c pluggable database schema, and created the objects, the employee details table inside it to demonstrate the various functionalities which we can achieve using the VPDs. I've got, in terms of tables, I've got quite a few. So I've got one table which will be used as an audit table, and this is this I'll talk about this in more detail when we will be speaking about creating a database login trigger using the VPDs. And then I've got the default user roles table, which will be based on when I'll be talking about the context, using context in the VPDs. Then I've got a policy details table. So this table is not a must, but it is in terms of the day-to-day management of the policies. You can keep them locally and then reuse them, modify them, then reuse the same, just pass the policy name and then pass it to a procedure or a function to just create that for you. But because this table holds all the metadata for that policy, so you can easily manage that locally rather than passing the arguments to the procedure to create the policy. So that, going back to the document. So I've got a table called employee details. And as I said, I've created that table using basically a joint query, and I've just inserted all the rows, resulting rows into a new table called employee details. It has got employee ID, name, email, phone number, and various details. And then I have created another column, which is called the application role. Now, the application role, why I've created is because, in my opinion, the VPD policies should be simple enough to return the predicates, and we should not make them complex, because otherwise it might result in the error if something unusual happens, or something which it can't accept as can't produce as a filter predicate. Then, as I said before, that the policy function will return an error. So any table which you want to secure using the VPD, there should only be a couple of columns, or I would say just stick to one column, which will identify that a bunch of rows belong to what kind of app role, or whatever the column which you're trying to define the security on, to which the rows should belong to. For this purpose, I've just used the department name, and I've just created the app role just exactly similar, except replacing the spaces with underscore, so that it just doesn't causes any issues if there are spaces. It shouldn't be ideally, but I just created it in that way. So I'll be using this app role column to just demonstrate a simple scenario. So this is a simple function. So I'll be creating that inside this. So what it is doing is, as I said, it is accepting two parameters and then returning a string predicate. And I'll come to this later, that how much what the predicate can produce as output. It can produce normally, when you don't explicitly specify to produce it, the long predicate, it can normally produce up to 4,000 characters. So what this function does is it says that if the object owner, which we pass through, is the schema user, which means if the object which on which we are creating this policy is owned by the logged in user, then don't do anything, just return null. Otherwise, the predicate should be anybody else who sees it should have the app role as IT, which is defined in this table. So if we query the employee, yeah, right now there is a policy. So what I'll do is I'll just drop it. So sorry, there was an existing policy. So before this session, I was doing some final rehearsal. So yeah, so if we query the table where app role equals to IT. So there are, as we can see, there are just 5 rows which belong to the app role IT, or let's say department, which is IT. Now, if we create this function, which basically tells that any user other than the schema user should only be able to see the rows belonging to this. Let's create this function first. And now what I will do is, so the policy details table, I'll just query that table. So this table already holds, which is package, which I'll be demonstrating in a few minutes. So what I'll do is, instead of using this package, I'll update policy details set policy function name to app role function. And the schema is utils, and there is only one row, and it is not context sensitive, so I will make it policy type as dynamic. I will talk in more detail about what are the possible options in terms of the policy type. And I'm not using a long predicate, it's quite small. I'll just remove the policy namespace, mark it as null. And then namespace attribute. Also should be null. Anything else I should be taking care of? I think that's pretty much it. Yeah. And I'm calling it the same policy because it doesn't exist in the spelling mistake. What is that? Okay, so instead of using the default package, we are now using the app role function, which we just created to demonstrate a very simple use case of this. And I've kept the policy type dynamic, which I'll explain later. What all are the possible options with this? So now the only thing which remains is to create this policy and attach it to this. For that purpose, what I'll do is I'll just show you what API we use in terms of when we create the policy. So as I showed you earlier, we use the dbms underscore rls.add policy procedure to just attach any policy. It accepts in terms of the arguments, object schema, object name, the policy name, function name. I think these are pretty much self-explanatory. So only the arguments which are basically need some explanation, I'll be explaining them. So in terms of statement types, when we say it can accept a select statement, an update statement, and delete statement, and an index statement. What does that means is when we specify, let's say, for example, select, only the select statement, that means whenever we will be querying the table or whenever we're selecting the data from the policy attached table, only the select statements are going to be affected by that. So if we do the delete or update or insert or index on that, it's not going to use that policy function. But if we specify all the various DML statements, then I think it impacts all of those. Then we have update check. So based on what we store in the policy details table, it basically decodes them and then says if it's true, then it's true. What does that in principle, what does this means is that before adding the policy or before doing any updates on the table, it will first check and commit the changes and then do the rest of the stuff. And enable means you can create a policy as disabled and then enable it later. So by default, it takes as true. So it always creates the policies as true if we pass it as true. And then static policy. So static policy basically means when the optimizer basically creates the transient view and on a policy attached table, it checks the predicate and it stores into the shared area, and then it just assumes that every time the value is going to be the same. So it doesn't pass statement again for basically checking what the policy should be returning, because it knows that the policy is defined as static, so that values is not going to change. So it uses that. It is, in general, it's not a good idea to have a policy as static. So here there are different kind of policy types. So static means, as I explained. Shared static mean that the policy is basically unless something changes in the sequel, it is going to be static. But if anything changes, then it is going to be refreshing that store statement and then uses the new one. In terms of dynamic, it means that every time the function gets executed, when the policy function gets executed. So generally, by default, the policies are all policies in Oracle when we create it as dynamic. Context sensitive means that when we attach a context to a policy, then it uses that context attribute and while evaluating the final predicate. And the shared context sensitive means the same thing. Every time the context value changes in the session or by any other session, then it refreshes what is stored inside the shared area. Otherwise, we just when it's null, then it's going to create it as a static type. So that's how it works. Long predicate, as I said. So if you want to make the policy predicate or the where clause, which is returned by the policy function, really long and complex, and it basically means that you can return 32K value out of it. Otherwise, by default, it returns 4,000 characters as the policy predicate. So the table, which is the policy details table, it allows us to do that. If you define that, then it's going to create it's going to allow your policy function to return that. Then the secured irrelevant columns. It means that if you want to enable column level VPD, which means that with the row level VPD in place, if you want to secure some of the columns as well from saying from other people's saying, then you can define the columns in that particular table, that which columns you want to secure. In which case, the policy, what it does is it just returns nulls, replaces the values with the nulls so that nobody can see them, or the people who are not supposed to see them can't see those columns. And the options means, so this security element column options, it basically has got two things to it. I think I've got them in the document. Yeah. So the security relevant column option has got two behaviors. One is the default behavior, which says it restricts the number of rows written by the query. Also, and then it basically, when any other user queries that, it returns null. And another one is column masking behavior. So it basically defeats the, to me, I think personally, it defeats the purpose of the VPD if we use, I think, dbms underscore rls dot all rows, because in that case, what will happen is the columns on which we've defined the policy will be turned as null, but the user will be able to see all the rows. So it kind of defeats the purpose. So instead of using the column level security, I would suggest rather wrap that table into a view, just exposing the required columns, and then apply a security policy in terms of the row level security. So I think in general, I've never seen or never seen anybody applying the column level policy unless, of course, there's a specific purpose attached to it. Then let's jump on to, yep, there are no policies. So I'll use the same procedure which I just explained. So this procedure basically takes the argument as policy name and then queries the policy details table and then creates it accordingly. All right. Okay, so we've got the policy in place. And as you can see, have you got any questions? Okay, where can I see it?
Okay, so we had a little question come in from Joseph. He's saying, why would you use column level security for something like hiding social security numbers? You got there?
Have you got the question? I can't see it.
It's okay. So it's saying, why would you use column level security for something like hiding social security numbers? You got
I mean, is he asking like, why would I use or why would I not use?
Why would you, or would you use it? Would you use?
Yeah.
Would you use it? Sorry, I'm getting
okay.
it.
Okay, so as I said, so if you basically say in the security level column options, if you say that dbms underscore rls dot all rows, if you give that option, then what it does is basically it invalidates your row level security and then makes all the columns in your question, based on your question, the social security number will be displayed as null, but the initial policy which you created will be kind of no use, because it will return all the rows, so you can see all the rows. And I'll show you right after this that how it basically impacts, or basically is not a good idea to have it. And there are certain restrictions around it. If you have a column level policy in place, then the predicate should be simple in terms of you can't define the complex predicates to be returned by the policy function, and also you cannot create column level VPD onto the sequence on the synonyms. So in general, when you look at the large applications and the objects are shared across multiple users, then we've got public synonyms in place for the users to access them. So if you have got them, then I think you can't use the column level security. Does that answer your question for now? But yeah, for sure, I'll show you why it's not generally is not a good idea to have the column level and the row level security coexisting.
Okay, so that's good. So basically, it's a bit limited in terms of what you could do. So Joseph's got a follow-up and says, how would you do something like that? So have you got an example coming later? I think you were mentioning something.
Yeah.
Okay, so yeah, continue
Okay.
then. See.
Okay. So I think so. What we did is we have created a policy. We've got a policy function in place. We created a policy, and that policy is attached to the employee details table, which belongs to the HR user. So let's get into the HR user and then query this table. Okay, so we've got 107 rows, as you can see, and HR user, because it's a schema user of, and he owns that table, he's not restricted from seeing any information from this table. But when we go to the utils user and then query, as you can see, because the policy in place, it automatically returns just the rows which belong to the app role IT. So that's what the policy suggested in terms of the predicate. So that if you look at the policy function again, you can see that we defined the predicate, or in other words, the where clause to be returning as app role equals to ID, only the rows which it should be returning. So does that make sense? And we'll move on. So I've given this attribute as all rows, and I'm hiding the email, phone number, and the salary of this. So we'll see once it gets created, and I can see there are 2 policies in place now. And basically, we don't need to have 2 policies in place for this. We can modify the existing policy, which is AMP policy, and add these 2, just populate these 2 rows instead of passing them as null. So it basically depends on the preference of how you want to manage the policies. I would say just use the same policy and then append them. Now, if we query this, I think I need to drop that existing. As you can see, the email, the phone number, and the salary, all of them he can't see for other users, but he can only see them which belong to the department IT. So that's what I said. So it kind of defeats the purpose, because he can still see all the other rows and the various other information available. For example, the in terms of let's say what department he works on, or the job title, the hiring date, and the employee ID. So all this information he can still see. But when you have the row level security in place, he can only see the information which is meant for him. So that's why I said that if you really want to hide the columns, you should basically wrap that table inside a view, just exposing the columns which you want to, which the user is supposed to, and then create a RLS policy on that. So does that answer your question, or you want me to?
Okay, well, he felt. Oh, he's saying it does answer his question. So thanks for explaining that.
Yeah, no, so for some reason I can't see that questions window. Okay.
Yeah, it's all right. I'll keep an eye on the questions and just relay them to you if there's anything else that comes in.
Okay. Right. So these examples which I showed you is a general introduction. But when we talk about implementing it into an application and then exposing it, or basically aligning the users to these policies, we should have a mechanism in place to first of all manage this. So for that purpose, I think I've already explained, we've got a table and a package in place. So this package has got several APIs, I think. So we've got a get policies function, which basically fetches anything from the policy details table. Then we will create policy, delete policy, recreate policy means if you have changed something in the policy. For example, if you have added in context or anything else is changed in the existing policy from the policy tables details, then you can basically call the same policy name, and what it does is it eventually checks in the database, drops the policy, and then recreates the same policy again and attaches it to the same object. Then we've got the set context VR and a generic procedure which will be exposed, which can be exposed to the end users without telling them what the context name is. They can just set the value of it. And then similarly, the get context, what is the current value, and without any parameters, because by default, if you have defined a context, a single context, then it doesn't make sense to expose those details to the end users. You can just see what context they are currently in. Speaking of context, so I think in general, context, what they mean is they are a key and value pairs in general programming terms. So you define a key and then you assign a value to it. So that's what a context does in Oracle database. And you create a context using the create context command, and you should have create any context a privilege for that. And you should have dbms_session privilege. I think that requires sys.dbms_session privilege in order to set the context to any user. For that purpose, I think in general, we would want to give that privilege to an advanced user. In this case, is utils user. So, and then wrap that procedure inside a package and then expose that package API to the end user so that they don't have a direct access to changing the sys context or doing anything with it. Now, let's move on to.
Okay, but before we move on, we had another question came in from Vitor this time, and they're saying, when designing, building new applications, should every person/application have its own unique database user? What is the approach you use in your applications?
Well, it kind of depends. So you can have a table. For example, let's say an application users table, and you can store all the users which are supposed to access the application into that table, and then create a database logon trigger which checks that table whether the user which is trying to log in is an application user, or is it trying to access it apart from, is that user not an application user, and then basically let them in to the database or let them log in. I'll show you that. I think in a while I've got an example ready for that. So before that, I'll just explain briefly on the context sensitive VPDs, and then we'll move on. So does that make sense, or you want me to take that before?
Yeah, I think what you said makes sense. I think I've got a view that, I mean, these days saying every person having a database user, I think that's quite an old school approach that people who've used forms applications might have used a lot. So if you're still using forms, then I think having individual users, database users for real people, kind of fits with that model. But in terms of modern applications, it's more about using the applications. So I don't know what your thoughts are, if you've got any other comments.
Well, I mean, we can still have database users. So for example, if an application user is educated enough to use, let's say, for example, some users like to query on their own in using SQL Developer or a custom, what is a SQL query mechanism. They are good at writing SQLs, and I know few users who are quite good at writing SQL. So they basically want to have that database access. But yes, in order to prevent them from accessing any other objects which other than which they are supposed to, we should have a proper mechanism in place so that whenever they log in into a particular context, and then they can access only the information which they are supposed to see, and they shouldn't be able to access using any application other than which we define into the application users or the metadata table. I think that kind of makes sense. But yeah, I think I kind of agree with you. In the modern world, I think we don't want to create database users, and I think that's what RAS, the real application security, deals with. the next version of VPD. So it basically creates an in-memory in-memory user, and then doesn't require us to have an actual database user to implement the securities.
Okay, yeah, I think it's a great point. If you have people you do trust enough to give real actual access, like SQL Developer or Toad access to your database, then yes, it does make sense to give them their own users, doesn't it? So you can audit what they're doing, if nothing else.
I mean, there are users who use still ODBC connection, which query who query the data using their Excel APIs and stuff to write their own reports. So yeah,
Okay.
sometimes we kind of can't deny that when they want access, they get all the approvals and stuff, and then we have to create that. But yeah, we should have a proper security mechanism in place for them to basically not expose any other information which they are not supposed to execute or select.
Okay, cool. If you let us know, Vitor, if that helps answer your question. Otherwise, if you continue on.
Yeah. Okay. So I've got. So I don't understand. I can't access the question and answers window. Okay. Anyway, so I've got a context in place, an example context. So, and context is basically, the syntax is quite simple. You give a name to the context using a package, and the good thing about this is it doesn't validate whether the package exists or not. So in this case, that you can create this context even if the application security PK package doesn't exist. You just need to give a name to it, and then during the runtime, it validates whether that particular package or procedure which you have created it on as actually exists in the database or not. So in this, I've created this on this package, and then if you look at my actual application level implementation, which is not very complex, I would say, but I think it's simple enough, and we should keep the VPD policies as simple as we can to avoid any unusual errors. So let's look at my policy function, which I've defined using this context. Okay, so as usual, it just takes two arguments, schema name and the object name. And you've got a predicate returning. It can return 32K in this case. So because string type is defined as 32767, so it can return a long predicate if you define it that way. So we go to the policy function again. Yeah. So I've got a table in place. Let me open another schema browser here. So app user roles, and I've got a default user role. So when you have application context in place, you want to, whenever a user logs in, you want to assign a default context attribute to it, or a default value with which they log in into the database. And then you have got other user roles, like a user, for example, can belong to an IT department and then can belong to the engineering department, for example. So he should be able to see both the rows. The rows belong to both the departments and shouldn't be restricted by if the initial context which he logged in with was just IT or engineering per se. So if we look at this implementation, it gets all the user roles, whatever he's got, and it gets the default context using the get context function, which I just explained. So it checks whether if the default context is null, then it keeps it null, and else it just basically puts it into the single quote so that the predicate just gets accepted. And then the same check, if it is a schema owner, then don't do anything. He should have all the access to the table. And otherwise, what it does is it basically checks. So app role is the key column on the table which we are using for this demonstration on the employee details. App role is the key column which we are using. It checks whether the app role inside the default context or any of the roles available. Otherwise, it will just invalidate. Otherwise, it will become like x equals to y, which is not true, and user won't be able to see anything. So let's really quickly create a policy. So I'll give this name as context. Okay. I think this is the security relevant column side. At this point, I've already explained the column level security. I want to keep them null. Yeah, and I'm using the actual policy function now, and it is a context sensitive policy. And what does this long predicate is? It's not a long predicate, and it can be applied. Let's say select, update, delete. I'll define this, and the object owner is HR. The object is employee details on which this is defined. And let's create this. Okay, so we've got this policy in place. What we will do now is we will drop any policy which we had. So we will delete. Have we got this in place? First of all, let's see. The policy is in place. So I'll drop this. Okay, this is dropped. And policy CTX enabled. And I want to create this. Okay, so I think that's in now. So we have got the policy in place now. Now, let's query this. You can't see anything. And the reason for that is because we don't have anything defined for this user in terms of either the default role, there is no data, and there are no application roles. That user has nothing. So he's just a new user who's got no roles specific to that application. So he can't see anything for that table. Now, if I give, for example, so we know that the employee details table in the HR schema, let's use a different role type this time. Yeah, so let's keep the roles as sales. So if I insert, hold up, so we've got the rows back. That means the policy function is working, and he can only see the rows which are belonging to sales. Now let's do one more thing. Let's add one more role, and let's add IT as well. And then you can see that he has got the access to the rows belonging to the IT department as well.
Very nice, very nice. So we're starting to get close to the hour. I was just wondering if there's much more that you wanted to show us before we wrap up the session.
I think, one more main thing which I want to demonstrate is the logon trigger, the database, to just give more security. I've got a question, performance-wise, how does Oracle deals with the table with 10 billion rows? Yeah, I mean, to be honest, it impacts the performance, but not to very great extent. It depends on what your predicate returns. So that's why I said in the beginning that we need to keep our policy functions really simple and effective in terms of how they deal with. So each view or a table or a synonym you want to secure, basically keep one or two key columns. So, and you can create a bitmap index on them so that the performance is not impacted that much. But I think in general, I think you will not notice much performance difference in terms of how it affects the performance of using VPDs. But it does to some extent. If you look at the plan, then you will get to know more about it. But not a huge impact, I would say. So as you can see, when we have the roles in place, you can see now I'll do one more thing. Delete from app user roles. as we have only one user, I will not care about giving a where clause. So everything removed, everything back to normal. Now let's set the context. So we know the context name and we know the API. So real quick, application security pk dot set context function. Let's set it to IT. Okay, it should be a PR. Sorry. So if we see now, so we can see that the context is set. Query the employees table. That gives you, if you don't have any user role by default when you log in, you can have a trigger in place and set the context to IT based on what you define in the default user role. And now okay, got a question again.
So the question is, if the person does not have an Oracle database user ID, how do they log in if their information is in an application user table? Or do they require at least an Oracle database user account?
Yes, they do. In this case, they do. I think in the BPDs, I think we still need the user to be an Oracle database user. I think starting from RAS and the real application security APIs, we would not be having that requirement no more. So that I think as I explained earlier, so RAS basically extends this BPD further. So that will allow you to not have a mandatory Oracle user in place to apply a policy or set the securities for that user. But for this specific demonstration, I think we need to have a database user in place. But as I said, you can still make them as an application user by having a table in place and storing that user information, and then have a trigger on top of that to just check whether it's an application user or it's any other user, and then define or restrict the access based on that. And I'll show you just right away how this works. So I've already created a trigger for that. It's already in place. I've kept it disabled until now. What it does is in principle, it just checks, it audits the user. It checks when the user logs in, it creates an entry inside the table. Let me open another schema browser. I think we've got a couple of minutes left. So it basically stores the information whenever a user logs in inside this table. Various attributes. So IP address, the program name, the machine name, the username, the session ID. And once it does that, it again checks if the user is in these users. So util is in this case our advanced user, and we don't want to restrict sys and system users from logging in, then do nothing. Otherwise, open the default roles, check if there is any. If it is null, then see how many, if the user has got any application roles. And if it is greater than 0, then set the context to null, because if it is greater than 0, then the policy function is going to use the application roles to display the information from the tables on which the policy is applied. Otherwise, just say that access is denied, you don't have any default roles for this user. And in the first place, if it is not null, then log in the application user as with his default role. And in any other case, I think exceptions, I think that's pretty simple. So let's enable it and then see it in action. So after logon trigger, let me enable it.
Okay, well, while you're just typing that, I'll just ask if anyone's we're pretty much on the hour, so if anyone's got any last questions or comments, get them in now, and then if you show us how this is working, and then we can wrap up the session. Thanks.
Yep. So enable the trigger, and now what I'm going to do is
Okay, just while you're doing that, I see Joseph asking if we can have a link to reference information about setting it up without an account in 12c or later. We can add some links to the office hours session. So if you come back, we can add links there, Joseph, with extra information, any other links that we think are useful. So check the session back when the recording goes live. Okay, you about ready to do this?
Yep.
Cool.
Okay. Last bit. Okay. There you go. So because the HR user now doesn't have any default roles, anything defined in the table, so he can't log in. So in this case, I'm trying to demonstrate that HR is an application user and he's trying to log in without any default role assigned to him. So he's denied the access, but we will have a logging in place. We can see that it attempted and login using our, there you see.
Very nice. We can see
we can see the IP address, the time. So it's about 4. I think that's the entry. So around 4, he's tried to log in and he failed to log in. So this way, I think if that answers your question, this way you can prevent the application user from logging in, and you can extend that logon trigger with some more complex checks saying that whether it's application user, whether he's trying to log in using a particular application. For example, if he's trying to log in anything other than the let's say, for example, he's just supposed to log in into the application using a front end, for example, a Java front end or Apex front end or Oracle Forms front end. If he's trying to log in using any other application, you should deny the access or something along those lines. I think if that makes sense.
Okay, I think
Yep.
that was really good. Nice demo. Good demonstration of the power that we have in VPD. Thank you everyone for joining us, and thank you, Parveen, for giving this session. As I said, we'll have the recording available sometime later this week, so stay tuned for that. And hopefully next month, Stephen will be all healthy and back at it again, so you won't have to make do with me. Until then, anything final comments, Parveen?
No, I think so. We didn't cover the application policy group, but I think that's quite easy. It just helps to maintain certain policies within a group, and then you can enable or disable them in one go. I think that is pretty much self-explanatory in the documentation, so I think that's not that important. But I think we've covered most of the key concepts of it, and if there are any questions, then I think we can take them after this session.
Yeah. All right. Well,
Yep.
thank you very much. Thank you all
Thanks.
for joining us, and I hope the rest of all of you at home are safe and healthy and enjoy the rest of your day. So,
Yep.
goodbye.
Just bye.